आंटी So what I can say, the next topic for the day is feedback circuit. So we are starting with feedback amplifier. So what is effect? We want to know what is effect of feedback on circuit. So let's discuss this. Effect of feedback. So what I can say, that we are having this is, let's say, one amplifier having gain A सब कुछ बताओ। नहीं पता, नहीं पता। दीपक को पता, दीपक को। आगे थे एक बजे आए थे आज। तो आगे का जो नितिन का फोन आया था भैया बात है ना। आगे का मैंने बात दिया छोटी कर देंगे उसकी। देखो तो चाय पिला दी जल्दी की बात हुए पति पति और बालक नहीं बालक है यहाँ देखो उनको तो हम समझ आ गया आप जैसे बात कर रहे हैं बोल तो क्या लगा आपने अपने मन को जैसे तो कायदेसर शायद उनका फोन आ जाएगा। This is one feedback circuit. So this input is VO into beta. So I can say VI minus VO into beta times of A is equivalent to V out. This input is VI minus So this is open loop gain. What I can say, this is open loop gain. This is open loop gain. This is feedback factor. So we are having input gain and feedback factor. And what is effect of feedback? What I can say, the effect of feedback is desensitization. So you can say A times of Vi is equivalent to Vo plus A beta times of Vo. Or I can say the closed loop gain is equivalent to A divided by 1 plus A into beta. And what I can say, if A is much greater than 1 by, or I should say, if this number A beta is greater than 1, what I can say, if A beta is greater than 1, then what I can say, the closed loop gain is equivalent to 1 by beta. And what is meaning of this? The meaning of this is desensitization. तो अगर आपसे पूछा जाए कि what is one word answer, what is one word answer for the feedback? Why feedback is important? So one word answer is desensitization. Desensitization is one word answer for the feedback. है ना? It desensitized the gain. है ना? Gain is now not function of beta. So this is the meaning of feedback. Let's say we had discussed one feedback amplifier, and that feedback amplifier is this: common source, common emitter with emitter resistor. Common emitter with emitter resistor. Suppose this is the idea for the circuit. So what I can say, common emitter with emitter resistor, how it will looks like. So you can say this will looks like this. The function is this is RC and this is one feedback resistance. This is RE. This is my VI. So let's draw the small signal model and let's see gain. Who is providing negative feedback? You can say this resistance RE is providing negative feedback. Why it is negative feedback? You can say the logical expression for this is also given in the discussion of this. So what I can say, the best easiest way to calculate this is whatever you mixing with input is known as negative feedback. So what is the polarity with this two? You can say VI minus VI plus VF is equivalent to 0. So you can say this two input and feedback is having different signs. So this feedback is a negative feedback. Right. The mathematical way to find, otherwise we had a discussion how this stabilize the biasing point of the transistor. So this is the idea for the circuit. Now, what is gain of this? So I can say the gain of this circuit is given by this. This is your this is alpha into IE. This is RC. This is V out, or you can say this is GM into VB. This is another value of collector current. Collector current will not change. Then we are having one RE. This potential is VBE. Then what we are having? Then we are having RE. Then what I can say? This is our VI. This is the whole idea for the circuit. So I can say V output for the circuit is given by minus GM into VB minus GM into VB into RC. Or what is the value of VB? So you can say this current is what? VI divided by RE plus RE is the value of emitter current, correct? And what is VBE? So you can say VBE is equivalent to RE divided by RE plus RE into VI. So you can say V output for the circuit is equivalent to minus GM into VBE, which is RE divided by RE plus RE into RC. We know that GM into RE is given by alpha, and let's say alpha is approximately 1. I am taking alpha is approximately 1. So you can say V output is equivalent to V out by V in is equivalent to minus times of RC divided by RE. Why this is so? Because this is much less than RE. Now I can say the output the gain of this is only dependent on two resistance. It's independent to the device parameters. The gain of this circuit is independent to the device parameters. If this is independent to the device parameter, this is known as sensitization. So what is effect of feedback? The one word answer for effect of feedback is desensitize the gain. What is fundamental of this? It desensitize the gain. Desensitization is important. Now, the gain of this transistor is only function of the gain of this transistor is function of RC and RE. The gain of the transistor is only function of RC and RE. So this is the answer. It desensitizes the gain. This is the analysis of this is the utility of feedback. Why feedback is important? Because when your gain is dependent on beta or GM or any other device parameter, these all parameters are temperature dependent. So now your gain is almost independent to the device parameter. So this is the significance of feedback in feedback amplifier. Now, how you characterize the feedback amplifier? Let's see. It depends how you are, how feedback is provided. So we can say there are 4 types of combination. The combination is, let's say, one is output, and second one is feedback. So you can say this output is known as sampling network. You sample the point where you are taking feedback. And the point where you are mixing this with input is known as mixing. So how many topologies are possible for the feedback? You can say the first may be voltage sampling, and voltage mixing. This is one of the probability. The second one is voltage sampling, current mixing. The third one is current sampling, current mixing, and the last one is current sampling and voltage mixing. So these are the 4 topologies. These topologies are based on how we are sampling the voltage and current, and how you are mixing the voltage and current. So this is the idea. So let's start with the first one. Let's say this is my network. This is one amplifier network, and this is RL. Then we are having one beta network. Beta network is what? I can say this is my, oh, okay, let's magnify this so that we can understand it better. You can say the first is, okay, this is V output, this is RL, this is A, and this is, let's say, our input VI, and this is connected to output. This is our beta network. And suppose I want to test the voltage at output. So to test the voltage, how will you apply the network? Suppose this, we will use a pot, and suppose the 10 volt is output, you want to feedback 2 volts, then we will set the pot accordingly. So this is how we take feedback. So you can say these are two terminals from which at least you need two terminals to take voltage as a feedback. So this is, I am mixing this with, okay, and okay. So you can say this voltage is what? This voltage is V out. Now you can say we are having one more. This is beta into V output. What we can say? This is beta into V output. Now we want to mix the voltage. So what is idea to having mixing the voltage? Just if you want to add two voltage source, you will add it in series. So we will add in series. So what I can say, and this voltage is known as feedback voltage. This is plus this is plus, and this is minus VF. So this type of topology is known as, we are mixing the voltage. So I should say this network is known as sampling network. You know, this network is known as sampling network. And what you can say, this network is known as where you are mixing, you know, what is net input at the input of op-amp. Let's say this is the net input Vi, then I can say by applying one loop you can get the answer. Minus of Vi plus Vs लिख देता हूं मैं, whatever is input to the feedback amplifier, minus of Vi plus Vs plus Vf equal to 0. So you can say whatever the amplifier will get, now this signal is Vi minus of Vf. Whatever amplifier will get is Vi minus Vf. So I can say this network is what? This network is a mixing network. So what is name of this topology? The name of this topology is voltage sampling voltage mixing. And how you write it? We write this topology from this side to this side. We write the name of this topology from, keep this thing in mind. We write this topology from this side to this side. Now, so what is name of this? You are mixing in series. So name of topology is series, and you are mixing in series and you are sampling in parallel. So this is series shunt topology. The name of this topology is series shunt topology. इस topology का नाम क्या है? The name of this topology is known as series shunt topology. The name of this topology is series shunt topology. And this is voltage amplifier, of course. So what we expect from different type of amplifiers, you know, except good gain, what is the requirement? So let's talk about a requirement of a voltage amplifier. Requirement of an amplifier. Requirement of an amplifier. Requirement of an amplifier. So what I can say, requirement of an amplifier is what? The requirement of an amplifier is this. Requirement of an amplifier is this. What is requirement of an amplifier? I can say there are 4 types of amplifier. The first amplifier is a voltage amplifier. So you can say the first type of amplifier is a voltage amplifier. So what I can say, this is voltage, VI and V out. So you can say when input is voltage, output is voltage, you can say this amplifier is a voltage amplifier. Voltage amplifier, and V out is equivalent to A times of V in, where AV is voltage gain. Right? So you can say A is what? V out divided by V in. This is volt by volt. This is the idea. This is the first amplifier. What is second amplifier? The second amplifier is, you can say, input is voltage and output is current. And this is AG. So what is AG? AG, this is VI out can be written as AG into VI. So you can say I out by VI is equivalent to AG, and this is transconductance amplifier. This is transconductance amplifier. Right? What is next type of amplifier? The next type of amplifier is a current amplifier. So what you can say, what is current amplifier? We can say this is VI. Let's say input is now current and output is current. This is AI. This is I out by I in. This is current amplifier. And next to the last one is AR. Let's say input is what? Input is input is input is current and output is voltage, then AR is equivalent to VO divided by II, and this amplifier is known as trans resistance amplifier. So we are having this 4 types of amplifier, and let's see what is the requirement of resistance for this. What is the requirement of resistance for these amplifiers? Let's start. The first amplifier is a voltage amplifier. So let's draw the electrical equivalent of voltage amplifier. So now we are drawing the electrical equivalent. Electrical equivalent of a voltage amplifier. So what is electrical equivalent of a voltage amplifier? I can say the electrical equivalent of a voltage amplifier is given by this. Let's say this is your source. This is our source. Vi. Then we are having one source resistance Rs. Then we are having R pi, Ri, जिसको हम R pi बोलते थे. And this is your Vi. Let's say Vs. इसको मैं सोर्स बोल देता हूं, इसको बोल देता हूं इनपुट. लेट्स से दिस इज Vi. Now what I can say, we are having one dependent source. This is A times of Vi. This is Ro. This is V output. Let's say you are adding one load here. V output. Let's say this is a load. So this is the whole arrangement for this. What we expect that the value of Vi, we want this. The value of Vi must be Vs. This is the ideal condition. So what we can say, the Vi is equivalent to Vs divided by Rs plus Ri multiplied by Ri. So what is need for this? हम चाहते हैं कि जितना सेंसर पे वोल्टेज अप्लाई किया है सारा वोल्टेज वी के क्रॉस ड्रॉप हो जाए. सो व्हाट आई शुड से दैट RI divided by RS plus RI value must be 1, and this is 1 only if you cannot make change it RS. You cannot change RS because it is the source related voltage. So what is the condition? You can say RI must be as high as possible. अगर RI का वैल्यू अगर आपने जितना ज्यादा लिया है तो you can say RS plus RI is also RI. For R approaching to infinite, I can modify the expression and rewrite it RI divided by RS plus RI. So you can cancel this two because RS is negligible, है ना. मतलब I can say RS plus RI when RI is very high can be written as RI. So it's 1. So this is the ideal condition. So what we need for a voltage amplifier? We need the input resistance must be as high as possible. So what I can say, input resistance RI must be as high as possible. So this is the idea. Now, what is output resistance? We want the maximum output across load. So what I can say, we want maximum output across load. And to get maximum output across load, the value of RO must be as low as possible. So what is criteria for a good voltage amplifier? The criteria for good voltage amplifier is RI must be high and RO must be low. This is the ideal condition. That's why a voltage amplifier, a very good voltage amplifier known as op-amp based differential op-amp is having input resistance high and output resistance 0. So what is expected from a practical good voltage amplifier? The input resistance high so that no loading and output resistance equal to 0. So you can get maximum voltage out of this. So this is the requirement of a voltage amplifier. This is requirement of a voltage amplifier. So let's analyze one voltage feedback voltage amplifier. Let's analyze one feedback voltage amplifier. Let's analyze one feedback voltage amplifier. Let's analyze one feedback amplifier and how it works. Let's see. Let me take first this. So what is it? How feedback is helping? We are trying to identify how feedback is helping us to attain this condition: low input resistance, high output resistance, and low output resistance. So let's take one example. This is our circuit. Then we are having this is RI. Okay. Then we are having this is RO. And this is amplifier without feedback. Now what I am doing, I am mixing, I am taking feedback from this. In which type of feedback? I am taking voltage as a feedback. So I can say I am taking feedback from here. So you can say this is A into VI. है ना? A into VI, and what is VI? Right now you can say VI is equivalent to VS क्योंकि अभी कोई feedback नहीं लगाया है. So you can say this is my VI and this is same as VS. This is my VI for the circuit. Now what I can say, let's apply a beta network. So this is a beta network. This is beta network. So what I can say, in beta network, we want to mix it in series. So let's take output of beta network. So these are two outputs of beta network. This is beta into V output. And this voltage is known as feedback voltage. तो इसको हमने इससे मिला दिया and we are connecting this to this. This voltage is feedback voltage. Now we have modified our circuit. Now there is a modification. So what is the effect of at input resistance and output resistance पे क्या effect आएगा जरा इसको देखने की कोशिश करते हैं. Let's see. So what I can say, V output for the circuit, let's say V output for the circuit can be written as A times of VI. The output for the circuit is known as A times of VI. But VI is not input. The actual input of the circuit is what? Vs. So we can have the one more relationship by applying a KVL here. You can find the value of Vs. So you can say by applying KVL, what we can say, minus of Vs plus Vi plus Vf equal to 0. So I can say Vi is equivalent to Vs minus of Vf. So Vi is equivalent to Vs minus beta into V output, because the value of Vf is already, we know what Vf is. So you can say V output is equivalent to A times of Vs minus beta into V output. So what I can say, V output divided by A into Vs minus A into beta into V output. So you can say V output divided by V input for the circuit is equivalent to A divided by 1 plus A beta. So first effect of feedback is you have less gain, है ना? फीडबैक का पहला इफेक्ट क्या होगा कि सर्किट का गेन कम हो जाएगा, और ये तो ठीक है, ये हमने नेगेटिव फीडबैक लगाने से पहले ही हमको पता था कि whenever this feedback thing happen, the gain will be original gain divided by what? Divided by 1 plus A beta. Now let's say what is the input resistance. So can I say the next parameter we are interested in, we are just identifying how feedback is helping in it. So we are going for input resistance. The next one is input resistance, Ri. So can I say input resistance is nothing but this ratio. Let's say this current is I, then I can say Vs divided by, the supply voltage is Vs divided by II. The input resistance is what? This is input resistance. ना supply को छोड़ के जो भी दिखेगा, that is input resistance. And now new input resistance is, I am saying, input resistance with feedback. ना फीडबैक लगाने पे इनपुट रेजिस्टेंस कितना दिखा, हम उसके बारे में बात कर रहे हैं. तो लेट्स टॉक अबाउट दिस, हाउ दिस सर्किट विल वर्क. सो कैन आई से Vs divided by Ri can be written as RIF can be written as Vs divided by I input. Now we can say Vs divided by Vi can be written as, what is value of Vi? You can say VI can be written as I can be written as VI by RI. यहां से फ्लो होने वाला जो करंट होगा that is VI divided by RI. और ये RI कौन सा इनपुट रेजिस्टेंस है? विदाउट फीडबैक इनपुट रेजिस्टेंस है. सो आई कैन से दिस इज VI divided by RI. So RIF can be written as VS divided by VI into RI. Now what is value of VS? So you can say the value of VS is equivalent to what? We can find the value of VS by applying KVL. This is the result for VS. So you can say VI is equivalent to VS minus beta times of V output. And what is V output? You can say VI equal to VS minus A into beta times of VI. जरा देखें. What is the value of V output? So you can say V output is what? The V output, the value of V output is what? This. V output is A times of VI. So I can find the value of VI. I can have the value of VS. The VS for the circuit is given by VI into 1 plus A beta. Or what else I can say? RIF is equivalent to VI times of 1 plus A beta divided by VI into RI. So you can say RIF is equivalent to 1 plus A beta times of RI. So this is the advantage of feedback. हम चाहते थे कि input resistance must be as high as possible. और जैसे ही हमने क्या देखा कि when you are having feedback, the input resistance is increased by this factor. है ना? जो भी बढ़ेगा वो किससे increase करेगा? 1 plus A beta से increase करेगा. So you are having higher input resistance now in comparison to open loop. है ना? We are having higher input resistance we are having higher input resistance in comparison to we are having higher input resistance now in comparison to without feedback. In comparison to without feedback. So this is the idea for the circuit. And this is how this is how feedback is helping us to achieve what we want. Output resistance of a circuit. So how you get output resistance? You can say output resistance can be obtained by applying one test source. So let's say let's redraw the circuit and make Vs equal to 0. Let's calculate the output resistance. the output resistance. Okay. So we will apply one test source by making Vi equal to 0. So this is our circuit. This is Vs and I am setting this to 0. Because what is output resistance? Output resistance is resistance by making Vs is equivalent to 0. Then we are having what? This is Ri. Then we are having one. This is Vi. This is A times of Vi. This is Ro. Then you are having one feedback. You can say this will act as input as beta network. And output of this is connected to this. This is the whole network. Now we will apply one test source to this circuit. I will apply one test source, and this test source will draw current I test. So what is output resistance? V test divided by I test is equivalent to R out. So let's apply one KVL in this. Let's apply one KVL. Can I say this resistance is also V test? This is beta into V test, and this is plus, this is minus. So you can say plus beta into V test plus VI equal to 0. So VI is equivalent to minus beta into V test. This is the idea from KVL in this loop. And when I apply KVL here, I can get answer very easily, because it's a minus of VT plus RO into IT plus A times of VI equal to 0. Now what I can say, only one term is not having VI, so I can say VI can be written as minus of minus of VT minus of VT plus RO into IT plus A times of minus beta into VT. This is equivalent to 0. So I can take VT as a common. So you can say VT into 1 plus A beta times of RO into IT. So what I can say, the ratio of VT divided by IT by making Vs equal to 0 is output resistance, and output resistance is equivalent to what? Output resistance with feedback. It is RO divided by 1 plus A beta. So this is how feedback is helping us to achieve what we require as a voltage amplifier. What is we require as a voltage amplifier? Voltage amplifier, our requirement is Ri must be high. So you can say R in input resistance is previous open loop Ri into 1 plus A beta. जो क्वांटिटी इंक्रीज होगा वो भी 1 प्लस ए बीटा से इंक्रीज होगा, एंड जो क्वांटिटी डिक्रीज होगा, यू कैन से द फीडबैक रेजिस्टेंस इज RO divided by 1 plus beta. So you can modulate the resistance level with the help of feedback. We can modulate resistance level with help of feedback. So this is our take on why feedback amplifier is better than the open loop amplifier. So this is the idea. Now let's take the next topology. Next topology is what? Voltage input, current output. So let's draw this